Hello, how are you? It's me, Blayton, Gypsy King of the Cadet Force and a volunteer. I'm just online looking on the forum, and it turns out our new rag's been released, which always causes controversy. And today, there's an article that's of particular interest to me. Let's have a look at it, shall we? In a news section of the magazine called Cadet Life Hacks, this article offers us a way to uncrease your shirt on the go. It says, getting grief off your CO because your uniform has got crushed in your Bergen, nowhere near civilization, let alone an iron. Here's a way you can still make yourself look presentable. But if you're nowhere near civilization, what do you need to iron your shirt for anyway? If a bear shits in the wood, does it make a noise? If you're on your own in uncivilization, does anyone care if your shirt's ironed? Also, if you are in an uncivilized location, what's your commanding officer doing there? And why is he such a cunt that he won't lend you his iron? And where are you going to plug it in anyway? In fact, how are you going to boil this water? These are all the questions we need to answer. There's only one way we can do this. Engineering and science. Gonna need an ironing board. There's an ironing board. Now we're gonna need a shirt. Yes! Now we need some hot water. I think we'll use the kettle. Right, as said in the life hack, I've now got everything I need. I've got 2 mess tins and a thin towel, a crease shirt, a flat surface, and we'll use an ironing board because if I fuck up the worktop, my missus will absolutely stab me in the face. Yeah, I've got a source of hot water from a kettle this time. Although the kettle's plugged into a plug, I could just easily plug an iron in there. But for all intents and purposes, boiling water is boiling water. You can get that from anywhere. Right then, all we need to do now is apply a little bit of engineering science. For this, we're going to use the Fluke 1587 insulation meter fitted with a K-type thermocouple, which is this little fella here. Yeah, and obviously if I put my finger on this, you'll see the temperature changes. It's pretty rapid and it's used in industry as a standard measuring device. So we're going to be using that to measure the temperatures. And also, just to be a bit pimp, I've got this, the FLIR TG167 thermal imaging camera. So if I turn it on, if it turns on, there we go, we're coming on. And then you'll see that I can read things, and there's my hand. I can't quite get away, but I will be a bit so you can see my hand. Yeah, and obviously you can see where my hand's been. Oh, a lot of cool stuff. And that's how we're going to apply the science, motherfucker. So put my hand here now, look. You'll get to see my hand. But then what's going to be most interesting for us on this life hack is, when I remove my hand, my heat trace is left in the position it was. And we can watch as the temperature that deteriorates back down to normal. So, let's apply this science. Science time. Right, what I've done is, I've plugged this iron in as a benchmark. I know this iron's best for me on the high setting it'll go to, which is linen on MTP. So I've put it up to the high setting it'll go. I will leave that there now to warm up. Under this shirt, I've placed the K-type thermocouple. It is about here, and we're going to clock on, see how much heat transfer is involved for this iron to get a benchmark for our tests with our mess tins. These fellas. Let's go for it. Okay, so what we got, ambient temperature is about 18 degrees as we can see on this, although that isn't rare, just to prove that is on and it's not a duff video. I'm not one of them internet wind-up merchants. I'll put my finger on it, look, and you can see it's starting to rise, yeah? Just to prove the iron is on, we'll turn on the thermal imager. Yeah, and we'll point at the iron and we'll see what we get in. That is fucking hot. As you can see there, you're talking 204.3 on that. And on the shirt here, to get the heat transfer, you'll see that the shirt is rocking it about 21. Something like that. Let's have another go at that. Yeah, 20 degrees for the shirt. Right then, let's see what this bad boy can do. Rapid increase in the thermocouple there. Heat transfer is obviously taking through, all the way through. And I would say by now, that would be ironed. I'm happy with that. That's ironed. Is the iron on? The iron's on. Yeah, that's ironed. We've got the heat transfer of about 84 degrees. Let's try a bit of steam. Everyone wants a bit of steam. Bit of steam in there. Takes it up to way over 100, yeah? And it'll eventually rise to the temperature of the iron, but the shirt will burn by then. But anyone sensible now would have established that that shirt is done. And the heat on there now is dropping rapidly, as you can see. It's absolutely peeling off now, and it will soon below 100 degrees. So the benchmark for the iron is going to be about 85 degrees of heat required from the mess tins to make it work. Right then, experiment number 2. I've moved the shirt into a portion where it's not been ironed, yeah? And I've got my mess tins, and I've also got my thin towel. I've set the thermocol back up. It's still retaining a little bit of heat from the last experiment. Now I'm trying to get to grips with this text because it's absolute rubbish. So what you will need, a kettle, mess tins with a lid, a thin towel and a flat surface. I've got all of those, yeah? Boil a kettle full of water, which I'm going to do in a minute. Carefully pour the water into the mess tin, yeah? Put the lid on the tin. Right? These are standard issue mess tins. Everyone's seen these. Everyone knows what these are. This is what mess tins look like. Having a mess tin with a lid, yeah, that's on top, that's not a standard issue. The army don't give those away, yeah? So you need to be able to do these mess tins because these are what everyone's going to have. So the thing's wrong anyway, but the picture shows these mess tins, but the description is another mess tin. So I'm going to put water in this one and then place this one into it to try and keep some of the heat in. Put that one over the top. Then I'm going to use this towel, it says. Somehow I'm going to get that onto there while it's hot. Bunch it all up like this, and then I'm going to iron with it, even though it's friction on friction, yeah? So I've just decided that's a stupid idea. So what I'm going to do is, I'm going to fill this mess tin with water, put this mess tin on top to keep the heat in, flick this lid over, then use this towel to move the smooth surface across the iron. Because putting a towel, friction on friction, I'm not going to do a video on coherent friction, yeah? This is all about thermodynamics. But what I'm saying is, rough surfaces don't go together, especially if you iron. Otherwise, all irons would be fluffy, wouldn't they? So now I'm going to boil the kettle, and we're going to see what results we get compared to our last time. Right, this water's boiling now, quite rapid. You can see it's in the 90s, so I'm going to have to stop now, so I've got to get the water out. There it goes, right, here we go. I'm going to re-boil it and put it into the mess tin for the next bit of the video. Once. I'm going to boil it again, throw it into this, and see what we get on here. Let's go. Kettle's boiling. All the water we can fit in, so we get maximum heat transfer. Fucking hell, that's hot. Ow. This is dangerous, kids. Don't do it at home. There's the lid. The lid don't want to go on. Now there's water coming out. That's not going to work. Oh, the mess tin's gone in now. The mess tin's flat. There's water going everywhere. I'm going to grab this. Ow, it's hot. Now there's more water coming out. I'm scolding myself. I'm just going to place it on there because it's fucking dangerous. You bastard. Transfer level is 31. Ow. Now we've fucked the experiment up because water's gone everywhere. So that's just picking up that actual hot water now. And even with fucking scalding hot water being everywhere, it's only gone up to 42 degrees, even though the water's absolutely pissed all over the shirt, which is rendering the entire job useless. We'll just get a thermal image on there. I don't think that's ever going to clock what it wants to do. Yeah, it's like 40 degrees look on the shirt. The water's going off, all the heat's disappearing. Yeah, I've scalded my fingers. It's impossible to move around, so I'm going to have to try with a little bit less water. That's what we'll have to do. We'll have to give it another go. Right then. Went a bit wrong that, so I had to change it. What happened was water went everywhere, which meant it was recording the level of the water, not the thing. So I've set the iron up ready, look. So I've got a mess tin here. The thermal comes underneath it. I've had to move to a dry with the ironing board because the results are being squared another bit. I've put the unironed shirt at the top of it. I'm placing that mess tin on top of it, and I'm fill it with boiling water straight out of the kettle now. So we'll thrash the kettle up. We're all at the stand now because all was a bit tight, yeah? This is like perfect conditions. Will it iron it or not? We're looking to get about 85 to iron it properly. Yeah, the kettle's just boiling now. I'm not going to move it because I've just fucking scalded myself like I did last time. Yeah, I've burnt myself for science. Here we go, straight in. That in there. Lid on top. That on there. Bastard. See, water's still coming out. Yeah, water's still pissed out, and I only put a centimetre in, so the experiment's fucked. So we're going to leave it there before I really hurt myself. Now, there's just one last thing I need to do before I go, because I know what people are going to say. People are going to say, you didn't use a mess tin with a lid on. Yeah, and there's a reason why I didn't use a mess tin with a lid on, or I didn't make something lid on. That's because boiling water in a sealed container becomes a pressure vessel, and pressure vessels are really, really dangerous. So I'm just doing a quick experiment now. For a start, this kettle you'll see, there's a lid on it in there. Every kettle in the world has an open top. Things are free to come out of it. I'm going to use this thermal mug as a sealing lid to demonstrate what happens to hot water when it gets agitated in a sealed container. So we'll just wait for the kettle to boil and we'll move across to the sink. Right, the kettle's just boiling. First of all, I'm just going to take the water straight out of the kettle like I do with the mess tin and place it to the thermal mug and apply the lid. Yeah, so I'll do that now while we're on it. So it's boiling, wait for the click. Click, straight into there while it's boiling. It's stopped boiling now because of the temperature's dropped because it's left the heat for sufficient time. Just put that on there. I'm going to carefully put the lid on. Yeah. That is now a sealed container. If you press it, you'll get a splash. Yeah. If you agitate it, like when you're ironing, you get a splash of hot steam like that, which could end up going in your face. Yeah. Fuck's sake. Yeah. It's stopped now. Don't fuck around with hot water in tins. We are meant to inspire and teach young people, and we should do that by not teaching them poor quality science or things that are absolutely rubbish. Generally, these life hacks you see on the internet have no fucking scientific information in whatsoever. They're just a load of bollocks. Yeah? If you see them on Facebook or the internet or some shitty site, that's fair enough. But when a national magazine designed for us is reprinting them to people that may read it and then pass it on to cadets, yeah? People could read that, think it's genuine because they haven't got any scientific knowledge, which is fair enough because they might do a different job. Then they might tell a cadet that. Then a cadet might try and do that like I just did and burn their face off or cover themselves with scalding water. For God's sake, if you're going to say something to someone else, make sure you've got a proper source for it or it's genuine information. Don't go tarting crappy information involving dealing with liquids at 100 degrees out in magazines for people to pass on to kids, you fucking morons.